Hello, my name is Claudia ESCUE, and I'm a fourth-year PhD student at William & Mary. Today I'm going to talk about a project that Jenny KAHN and I have been working on where we explore intra-island production variability and pre-contact carrying capacity estimates on Rurutu, French Polynesia. Rurutu is in the Austral Islands on the outskirts of central eastern Polynesia, shown in pink in these boxes and these maps. In this project, we look at how Rurutu's in-use Taro terraces can illustrate pre-European contact subsistence through geospatial analysis and the integration of Rurutuan oral traditions and previous archaeological research. Our research broadly contributes to archaeological understandings of intensification and de-intensification and the role of surplus production and accumulation play in sociopolitical development. First, I'm going to provide a brief background on Polynesian agriculture. Polynesian agriculture can be divided into two sets of techniques, wet and dry. For the purposes of this presentation, it's most important to understand that irrigated taro is significantly more productive than dryland agriculture. An immense amount of labor would have been required to construct wetland terrace systems, shown here, as well as for their ongoing maintenance. As a result, taro terracing systems are significant in Polynesia because they've been linked to population increase, intense labor investment, and the development of social complexity and social inequality. The pre-contact sociopolitical structure of the Austral Islands has been categorized as open chiefdoms, where high-ranking occupational and ritual specialists such as warriors and priests could accumulate power through successes in warfare or religious accomplishments. Some argue that open chiefdoms result from sociopolitical devolution of a complex chiefdom as human populations reached maximum carrying capacity and strained limited island resources. We push back against this narrative by asserting that Rurutu's sociopolitical structure did not devolve from a paramount chiefdom, but rather that Rurutu's open structure was a unique response to the island's social constraints and environmental limitations, such as large makatea shown here, that cover 28% of the island, creating distinct differences in available arable taro land between districts. Our research poses three main questions. First, we ask, can contemporary wetland taro terrace systems alone be used to estimate pre-contact carrying capacity? Are contemporary systems indicative of the size and extent of pre-contact systems? And how intense are contemporary farming practices? Rurutu is an interesting case study to explore this question because traditional Rurutu and wetland taro farming practices have largely persisted from the pre to post-contact era, unlike other areas of the region like Tahiti and Hawaii. We then ask, what was the carrying capacity derived from wetland taro cultivation of pre-contact Rurutu? And how do such carrying capacities inform our understanding of pre-contact Rurutuan populations and population distributions? Modeling the carrying capacity of primary subsistence crops can serve as a proxy for estimating pre-contact human populations. Finally, we ask, how has the carrying capacity of wetland taro changed through time? To fully address these questions, we first situate our discussion in terms of the existing archaeological and ethnographic research on Rurutu. Rurutu and the Austral Islands in general are an understudied area of Polynesian archaeology. The island's taro terraces have likely been used continuously for an 800-year sequence, primarily through traditional methods like palm frond mulching shown here. However, agriculture has remained an unstudied area. We currently lack precise pre-contact population estimates for Rurutu. Missionaries in 1821 estimated Rurutu's population between 200 and 300 people, but population estimates made during this time period are problematic because this period was marked by large-scale population loss from European diseases. In 1938, an ethnographer named Seabrook provided a pre-contact population estimate of 3,000 individuals, and in 1969, archaeologist Ferrand corroborated Seabrook's estimation by using archaeologically derived house count data to predict the pre-contact population of one socio-political district, Vitaria, at 1,000 people, and extrapolating an island-wide population of 3,000 people. One goal of our project is to develop a preliminary pre-contact population estimate for Rurutu, using carrying capacity of wetland taro as a proxy combined with Ferrand's archaeologically derived house count data. To begin our geospatial analysis of Rurutu, we performed an in-depth analysis of the island's contemporary taro systems using GIS to determine probable annual yields. We used Landsat imagery of taro complexes from June of 2016 to determine plot area, the corresponding system it belonged to, and whether the field was active which is marked in green in these insets, or in fallow, which is shown in yellow. Fallow is a period of rest between planting seasons where soil nutrients can rejuvenate. Next, we determined R values, or rates of actively growing fields. Our analysis shows a 12% difference between Rurutu's highest and lowest R values, suggesting that equivalently sized taro complexes in different districts produce different yields. I've outlined some key systems in pink in this figure and blown them up in these insets. As you can see, systems 1 and 6 in the bottom insets have the highest R values, around 88%, while system 12 in the top inset has the lowest R value, around 76%. However, the island-wide average is 80%, which is similar to other islands in the region, suggesting that the intensity of contemporary Rurutu and taro production is on par with the rest of the region. In the next phases of research, we use this island-wide R value of 80% to estimate pre-contact yields. Next, we do a suitability analysis to locate dormant taro terraces, or terraces that are no longer in use by contemporary farmers. We identified 3 environmental constraints that constrain environmental features that constrain arable taro land. Perennial streams, such as the one shown here, are one limiting factor. A continuous source of water is vital for successful wetland taro cultivation. We use the location of perennial streams and gravitational flow modeling to determine suitable areas for wetland taro cultivation. Topographic slope is the second limiting factor. A digital elevation model shows that Rurutu's in-use taro fields are entirely in areas with a slope between 0 and 10 degrees. The last factor we looked at was temperature, using elevation as a proxy, where areas with an elevation over 100 meters were likely too cold for wetland taro production. Unfortunately, datasets on intra-island rainfall differences and geomorphic setting are not available for Rurutu, so we were unable to include this data in our study. Previous archaeological survey and excavations provided relevant data that we use alongside our geospatial analysis to locate dormant systems. 2 previous studies provide island-wide maps dating from the late 1960s and early 2000s that detail the location of swamplands suitable for taro cultivation. The best example of integration of archaeological data can be seen in these images, where we determined a road outlined in yellow and an ideal location for taro cultivation was built after the 1960s. Therefore, the area highlighted in red was likely used for taro cultivation in the past. Oral traditions provide negative data detailing the least likely locations for dormant taro systems. Oral traditions collected by Seabrook in the 1930s describe ongoing conflicts between Peva and Vitaria, as Vitaria vied for arable taro land. However, warfare was not the only means by which Vitarian chiefs secured taro from Peva. Vitaria also cultivated dryland crops, such as breadfruit, shown here, and traded for food, which suggests labor communities were not predestined to warfare over resources. Oral traditions show that these communities had agency and responded creatively to environmental constraints. We combined geospatial analysis and archaeological data to predict the most probable locations for Rurutu's dormant taro complexes. The orange areas are the in-use systems, and the dark red polygons are the 20 suitable areas we located for dormant taro systems. Vitaria lacks any potential areas for dormant taro systems, while Peva has expansive areas that would have been suitable. As you can see, many districts like Peva have undergone significant shrinkage in taro terrace use from the pre-contact to contemporary eras. Preliminary survey that I did last summer suggests that this GIS model is accurate, as I located abandoned but previously used earthen terraces and canals in areas where we hypothesized there are dormant systems. You can see one of these large embankments outlined in pink in the bottom left picture. The upper left image shows a flooded dormant field, and the right image shows a dormant water control feature. Further survey is required to determine if other predicted areas also show physical evidence of dormant terrace systems. After locating the dormant systems, we derived annual yields using formulae extrapolated from previous ethnoarchaeological research conducted by Pat Kirch. We use probable annual yields as proxy data to predict pre-European contact carrying capacity. In order to validate our formula for annual yields, it was first used to model contemporary Rurutu carrying capacity and compare our results with the most recent census data. Our method estimated the contemporary Rurutu carrying capacity at roughly 2,900 people, which could support the 2017 census population at roughly 2,400 people. Therefore, it's reasonable to assume that our formula can provide a valid carrying capacity estimate for pre-contact Rurutu. One problem in carrying capacity estimation was determining what percent of pre-contact Rurutu and caloric intake came from Taro. We believe 70% of a 3,000 calorie per day diet is most accurate based on the most recent dietary studies in the region. All in all, we predict pre-European contact Rurutu had an island-wide carrying capacity of roughly 5,800 people. We explore change through time of carrying capacity of wetland taro between socio-political districts by comparing pre-contact carrying capacity estimates with contemporary estimates. Our results show that the largest carrying capacities likely shifted from Peva in the pre-contact era to Avera and Morai in the contemporary era. Significantly, our model suggests that the carrying capacity from wetland taro in Peva, outlined in pink, decreased over 90%. Furthermore, a 49.1% reduction in island-wide carrying capacity illustrates the impact of system abandonment in the wake of European contact, introduced diseases, and population loss. We hypothesized that Rurutuan taro farmers responded proactively to colonial-era population loss by consolidating their subsistence efforts to a smaller number of systems and/or a restricted surface area to support a smaller population. In this way, dormant fields may represent intentional choices of Rurutu communities rather than the devolution of pre-contact societies. Next, we use GIS and Vern's house count data to make preliminary estimates on the island's population and population distribution. We use our carrying capacity model as proxy data to estimate pre-contact population for districts with the potential for wetland taro cultivation. Our carrying capacity model suggests that Rurutu population supported by wetland taro cultivation could have reached 4,300 people in the pre-contact era, which is roughly 75% of the total carrying capacity. As our population equation assumes population as a function of probable annual yields of taro, it excludes Vitaria and dryland subsistence strategies, so we integrate Vern's population estimate for Vitaria of 1,000 people. Therefore, our total pre-contact population estimate is 5,300 people, with the largest populations in Peva and Vitaria. We argue that Seabrook's island-wide population estimate of 3,000 people was likely lower than the island's pre-contact population. Our findings confirm that, like other Pacific Island contexts, post-contact population decrease was both extreme and rapid in Rurutu. Our results suggest that Rurutu contemporary wetland terraces alone are not suitable for estimating pre-contact carrying capacities, as the total area that may have been cultivated in the pre-contact era is 87.5% larger than the in-use systems. Our results empirically demonstrate that annual yields of wetland taro cultivation varied significantly between Rurutu socio-political districts. Unequal distribution of wetland taro between districts was likely a key contributor to the intense competition in the pre-contact era over taro. Our geospatial data in conjunction with Vern's house count data suggests significant differences in pre-contact population at the inter-island scale, with the largest populations residing in Peva and Vitaria. Regarding change through time of taro cultivation distribution, we argue that shifts in where taro is being cultivated from Peva in the pre-contact era to Morai and Avera, shown here in the contemporary era, suggest proactive responses by taro farmers to changing global situations. Broadly, our findings speak to the resilience of the Rurutu community, as they and their traditional practices, such as the use of the digging stick, shown here, have persisted through 200 years of European colonialism. We return now to our opening discussion of surplus production and its significance to socio-political development in Polynesian chiefdoms. We assert open societies, such as those found in Rurutu, did not devolve from complex chiefdoms, as marginal island environments likely never supported the large population sizes, stringent socio-political structures, and intense surplus accumulation required for a complex chiefdom. As populations pushed the environmental limitations of their islands, Local social structures, economic mechanisms, and religious frameworks allowed for the long-term resilience of communities in open societies. As such, the fluid sociopolitical structures found in open societies may have facilitated the persistence of the Rurutu community and their unique culture. Thank you for your interest and attention today.